One model you can use to forecast revenue is something called the simple exponential smoothing model. So what I'm going to do is I'm going to copy all the work that I've done here. We'll move or copy. We'll just create a copy and put it before what we just did. And I will call this SES, that's just for simple exponential smoothing. I'm going to clear out. We won't need quarter for this model. So I'm going to delete the quarter. And I'm going to delete all of our hard work we just did, but it's saved in another file. So all these things can actually go away too. All right. So what we're going to put in this one is in column C, this will be exponential smoothing. That'll be our forecast. In column E, we're going to use something called alpha to run our model. We're going to calculate error with respect to mean square error and also mean absolute percentage error. And the alpha box, just for now, we'll solve for it shortly, but let's just put in a placeholder for now that's valued at 0.25. Next, what we're going to do in C2 is we're going to enter the formula for our initial value. So to start this, it's actually just going to be equal to that period's sales. And then the model will be as follows. It's going to be equal to the previous month, C2, plus the alpha now, F1 anchored, multiplied by the difference between the actual sales in B2 minus the forecast. And then we're going to send that down. So you can see, let's actually graph this and see how well it did. Okay. So I'm just going to do an insert, recommended charts. We'll just do this first one for now. And you can see that it's not doing that great a job. So what we're going to do is change alpha such that it minimizes the error. So next step is we need to put in our errors. So in F2, the following will be the function. So it's going to be sum xmy2, parentheses. This does the sum of square errors. And we'll put in B2 to B32. Let's go ahead and anchor that. All right, so it won't. So sum x my2, b2 to b32, comma, c2 to c32, comma, so you can see that it's going to do all of our data. It's kind of a benefit of this too. It's going to use all the data. So in that parentheses, and then we'll divide it by the count of one of those arrays. So c2 to c32 will be fine. That'll give us the mean square error. So you should get like 71,000 or so. Or, excuse me, 71 million. Next is the mean absolute percentage error. This is going to be equal to the average of, we're going to take the absolute value of the difference between from B2 to B32 minus C2 to C32, and that parentheses divided by B2 to B32. So the difference is we're taking the absolute value of it and then averaging that up after we do the division over time instead of summing the square errors and dividing by it. So it's a little bit of a different measure. This will be a percentage. So if you hit enter initially, it does work. Okay. Sometimes if you have an older version, you may have to do Control Shift and enter to get that to run, but in this case for me it worked. So that's a percentage. We'll do 2 decimal places above. Let's decrease that decimal for now and just have that amount. So if I want to minimize this and make this a better model, we're going to have to use a solver tool in order to do that. That will be discussed in the next video.